Today we will do exercise 1.1. First question, use Euclid's division algorithm to find the HCF of. First one is 135 and 225. Let's see how to do this. So Euclid's division theorem is dividend equals divisor into quotient plus remainder, where 0 less than or equal to remainder less than divisor. So here in this question we have to find the HCF. HCF means highest common factor, but you have to use this division theorem. Let's see how to do this. In this question, 225 is the greater number and 135 is the smaller number. So take 225 as the dividend and 135 as the divisor. Now you have to divide this. If we multiply it with 2 5s are 10, 3 2s are 6, 7, 270, which is greater than this, so we can use only 1. That is 135. Minus it, 5 minus 5, 0. Here 12 minus 3, that is 9. 12 minus 3 is 9. 90. So the remainder is 90. Here dividend is 225, which is equal to divisor 135, quotient is 1 into 1 plus remainder is 90. Here remainder is not equal to 0. So we have to divide until we get the remainder 0. Now we have to take this remainder and this divisor. This divisor will become dividend 135 and this remainder will come as divisor. Like this. Now you have to find the quotient and remainder. If the remainder is 0, we can stop. 90 multiplied 2 is 180, so only 1 will come here. 90 minus it 5. This is 45. 13 minus 9 is 45. Here again the remainder is not equal to 0. Here the remainder is 45. So we have to do the division again. Take 90 as the dividend and 45 as the divisor. We know that 45 into 2, 5 2s are 10, 4 2s are 8, plus 1 9. So here we get the remainder as 0. So we can stop dividing the numbers because remainder is 0. Therefore HCF is the last divisor. HCF is this divisor. So we can write that HCF of 135 and 225 equals 45. Maybe most of you learned this method in the previous classes, but the teachers maybe don't tell you the Euclid's division theorem and all. But I know that most of you are familiar with this method. Second one, 196 and 38220, 38,220. So here the greater number is this one. So this is the dividend and 196 is the divisor. So we can write like this, 38220, 196. First, if we multiply by 2, 2s are 12, so are 18, so 2, 3. It will not come, 392 will come. So only 1 is possible. 196 minus it. 12 minus 6 is 6. Here 17 minus 9, that will come 8. And here 2 minus 1, 1. Now bring this 2 down. Now this is a big number, so let us do with starting from 9. 6 9s are 54, 9 9s are 81, 81 plus 5, 86, 8, 9 1s are 9, 9 plus 8, 17. So 9 will come here and 1 7, 6 4. Minus it, 12 minus 4, 8, 15 minus 6, it will come 9 and this 7 minus 7, 0. Now bring the 0 down. Now here 196 multiplied by 0 comes, so let us multiply with 5. 6 5s are 33, 9 5s are 45, 45 plus 3, 48, 4, 5 1s are 5, 5 plus 4, 9. 0. See, our remainder is 0. Remainder is 0, so we can stop the division, and HCF of 196 and 38,220 equals 196. When you get the remainder 0, you can stop dividing, and that the divisor will be the HCF. Third one, 867 and 255. Always take the greater number as the dividend. So here 867 dividend and 255 divisor. Smaller number should be the divisor. Now here, this one we can take the first quotient. It will come 3. 5 3s are 15, 5 3s are 15 plus 1 16, 3 2s are 6, 7. Now subtract it. 7 minus 5, 2, 6 minus 6, 0. So here the remainder is not 0, so we have to divide it again like this. Take this divisor as the dividend, and 102 remainder as the divisor. So we are taking the divisor and remainder. Remainder will come as divisor, and this divisor will be the dividend. Here we can do it with 2. So 2 2s are 4, 0, 2. Minus it, 1, 5, 51. Again the remainder is not 0, so we have to divide it again. So take 102 as the dividend and 51 as the divisor. 2, 5 2s are 10. Now we got the remainder as 0. So we can stop this, and our HCF is the last divisor. So HCF of 867 and 255 equals 51, like this. Next, question number 2. Show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. So let's see how to do this. Here we can take a is any positive odd integer, and we apply the division algorithm with a and b equals 6. We know that by Euclid's algorithm, a equals bq plus r, where 0 less than or equal to r less than b. Now we know that here a equals b is 6, 6q plus r, where 0 less than or equal to r less than 6. Now we can write the possible values of r. So r equals 0. We can write 0 because r is less than or equal to 0. R is 0, r is 1. So r's value will come between, including 0 and 0, 1, 2, 3, 4 and 5. We cannot take 6 because r is less than 6. 0, 1, 2, 3, 4 and 5. So the possible values of r are 0, 1, 2, 3, 4, 5, because r is less than or equal to 0. That is why we take 0 here. And we cannot take 6 because it is less than 6. So till 5 we can take. Now we have to put these values in, put the values of r in this equation. So a equals 6q plus 0, which is equal to 6q. A equals 6q plus 1. In this equation we are substituting. That is 6q plus 1. Then a equals 6q plus, when r equals 2, a equals 6q plus 2. This is when r equals 0, when r equals 1 and when r equals 2. When r equals 3, a equals 6q plus 3. When r equals 4, a equals 6q plus 4. When r equals 5, a equals 6q plus 5. Now q is some integer. In the question it is given that q is some integer. So if q is equal to 1, we can write 6, then 2, then 6 2s are 12, 6 3s are 18, 6 4s are 24, 6 5s are 30, 6 6 are 36. Like this, the table of 6 will come here. So here, this is even. Now 6q plus 1. That means 6 plus 1 is 7. 6 plus 12 plus 1 is 13. 18 plus 1 is 19. 25. Like this it will go. 6q plus 1 is all the numbers are odd. 6q plus 2. That means 6 plus 2. 6 plus 2, 8. 12 plus 2, 14. 18 plus 2, 20. 24 plus 2, 26. All these numbers are even. So this is even. 6q plus 3. 6 plus 3 is 9. 12 plus 3, 15. 18 plus 3 is 21. So these numbers are odd. 6q plus 4. 6 plus 4, 10. 12 plus 4, 16. 18 plus 4, 22. So 6q plus 4 means it is even. 6q plus 5. 6 plus 5, 11. 12 plus 5, 17. So these numbers are odd. Hence we can conclude that, see, 6q plus 1, 6q plus 3, 6q plus 5, all these are positive odd integers where q is some integer. Therefore, we can write any positive odd integer is in the form of 6q plus 1, 6q plus 3, 6q plus 5, where q is some integer. Where q is some integer. Number 3. An army contingent of 660 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? In this question, you are asked to find the maximum number. Maximum number means you have to find the HCF. So here you have to find the HCF of 616 and 32. By Euclid's algorithm, we know that A equals BQ plus R, where 0 less than or equal to R less than or equal to 32. So A equals 616 and B equals 32. We can divide. Here the greater number is 616 and smaller is 32. So take 616 as the dividend and 32 as the divisor. So here first 1 will come 32. If you are taking 2, it will come 64. 11 minus 2, that is 9. 5 minus 3, 2, 6. Here 11 will come and here 5 will come. Now we can take here 9. 2 9s are 18. 9 3s are 27. 28. Minus it. 16 minus 8, which is 8. Here 8 will come. 8 minus 8, 0. So our first one is dividend equals divisor P into quotient 19 plus R is 8. Here the remainder is not 0, so we have to do again. 32 we can write 32 as the dividend and 8 as the divisor. 8 4s are 32. 0. 0 will come. So we can stop dividing and the divisor, this divisor is the HCF. Therefore we can write like this: dividend equals divisor multiplied by quotient plus 0. When we get the remainder 0, this divisor is called the HCF. So 8 is the HCF. So we can conclude as HCF of 616 and 32 is 8. Therefore maximum number of columns in which they can march equals 8 columns.